So the next thing we're going to talk about and is to show you some of those visualizations that are very critical to success. And I'm going to ask Bruce Brownlee, our product manager for the Glimpse product, to take you through the next portion. Bruce?
Thanks, Lee. In this case, we have a multi-echelon supply chain problem with some special features to it. This is a related problem. We have a food distributor in Florida that ships 27 million cases across Florida each year with around 50 to 70,000 products. It varies by year. And so we had to make our stuff visual for them so that they could see everything at a glance. So in this slide, we're seeing the Florida locations and the size of the warehouses, the main distribution center in Miami, and then the main regional hubs here in Orlando and Jacksonville. And each one of these regional hubs feeds into remote distribution centers. So Jacksonville feeds into Tallahassee, Orlando services Fort Myers, and of course, Miami serves all of them. And in this case, we have a month over month of forecast available to us. So we do have that. And we had some transshipment issues where we can transship from any location to any other location, typically from the main hub to the regional hubs and then down to the smaller distribution centers, or we can receive limited quantities of goods at the remote distribution centers. Of course, they have limits on the truck dock capacity and also their ability to store stuff. They have smaller warehouses. So there's a summary view that we provide. And in this one, it's actually kind of a calculating view because over here we have the ability to set or change truck dock limits in terms of number of cases received and the minimum number of cases they can handle. And over here we have the increased demand. We have assumptions there so we can play with the demand in case we've under or overshot that in the real world. And then over here we have calculations on how many cases we're going to use locally, how many we're going to receive for transshipment to the downstream distribution center. And there's some elaborate details in here that we provide that the customer actually needs, and a Sankey summary that provides a very nice visual, lets us know how much we get from the vendor and how much we're actually transshipping and how much we're using locally. In the detail view, we actually show all the products, all 50,000 of them in the Sankey diagram that you did see. And then we summarize in a network flow diagram. It makes it really easy to see. Let's pick Orlando here for a second. Here we see them receiving under the current plan 6.5 million cases a year, and they're using local 6.5 cases, and they're receiving also 1.6 million cases from upstream. In this case, here we've got a solution where Tampa is receiving 500,000 cases a year, a little bit more than that, about 600,000 cases. And they're also taking in 600,000 cases from transship through Orlando. Through Orlando, and they use that 1.25 million combined locally. So this gives you a visualization, and as we change the parameters in terms of where we're going to ship, do more or less transshipment, these numbers adjust on the fly. We provide a least cost analysis to let the customer decide on their policies, like one of which is direct ship to the distribution center. Another one is transship everything from the upstream distribution center or hub. And so you can see our total cost for shipping by itself is 1.3 million for those products selected, 963K for transship, but the ultimately optimized cost, which has a mix of transship and local receipt, cuts their cost down to 919K. So just for the product selected, we can save them 100K on shipping costs. And then we produced a modified EOQ model for them that contains the ability to switch between order quantities depending on the cost of capital, the holding cost, ordering costs, and the domestic and imported product lead times. So if I pick a product here, let's take Surefine pineapple chunks just to look down and see what we got. We have three different options: quarterly ordering, order next month, and then we have a continuous review with a modified EOQ. So we can look at which policies are going to work out the best and produce the least cost. And so with this combined MEOQ, we're getting an optimal order quantity of 1.3K per order. And then, we see that we want to modify that to get a better result with it brings this out to 5.6K per order, and there was 5,600 cases on each order. And the reason being that the smaller order quantity wasn't sufficient to cover the order quantity during the delivery interval. So we have to order more to cover the demand during the period. Now, as you see here, if the cost of capital increases, which increases our holding cost, it dynamically lifts that curve just a little bit out to a bigger number. If the holding cost expands quite a bit, you can see then there are holding costs on the blue linear line, brings our original order best order quantity out. And of course, if the ordering cost increases, it is going to push that down quite a bit, so that we tend to order in larger quantities. But still, all said, we're still picking a larger optimal order quantity, but we are actually modifying that for this particular product to bring it out to make sure that we have enough to cover demand between orders. Now, let's pick a different product real quickly. This will be our last little piece here. So many. One day I'm going to modify this. There we go. We're going to do Caribbean butter beans. And in this case, you can see that if the holding cost is mid-range, then we've got a really high optimal order quantity, 3.2. And if it happens to be that my ordering cost is very low, then I order more frequently and order smaller quantities, 1.59K. But as you can see here, there's a faint line that shows where the optimal order quantity is, but that isn't sufficiently large to cover the demand that occurs during the delivery interval. So what do we have? We bump that up to 2.15K. If my ordering cost is a little higher, then the optimal order quantity is sufficient to cover the demand for us during the period while we're expecting delivery. So that's the kind of thing that we do, these interactive visualizations and glimpses. These are real time because this front end that you're seeing here connects to back end data. So the data is all real time. And given a known demand forecast here that we have for marketing, that gives us the opportunity to calculate each of these things and basically reduce our transshipment cost combined with our inventory and holding cost. Thanks, Lee.
Thanks, Bruce. Well, what Bruce has just shown you is some of the new thinking that Gartner has with the technology for 2022. One of the key pieces of that is now going to be known as decision intelligence. And what the key part behind decision intelligence is the ability to show interdependencies of data where you can tune the outcome for your specific model. If you noted, like on this particular slide, we may have one slider. If you looked on those slides that Bruce was showing earlier, we're able to look at that problem 14 levels deep. So there's 14 sliders on that. And while that might seem excessive, it allows the senior executives to tune the strategic outcome to see exactly where the model will be. So
yeah, I think the advantage there, Lee, is that your data analysts don't have to go out of the meeting and calculate a new set of data and come back in to just answer a what if question that comes up in the meeting.
That's exactly right, Bruce. Thank you.